Hi, in this video we're going to talk about the difference between population and sample. Now, our textbook definition of population is the complete collection of all measurements or data that are being considered. Typically, a population is the complete collection of data that we would like to make inferences about. In other words, it's the entire group that we want to make a conclusion about. The sample is a subcollection of members selected from the population. Now, the way it works is we have our entire population, and usually it's not reasonable or economically feasible to sample the entire population. So instead, we go out and pick a subset of the population and ask them the question. For example, if I wanted to ask the class a question like, what's your favorite sports team? All right, the population would be the entire class. But maybe it's not feasible to ask everyone in class. So what I would do is go and ask a sample, and the sample would be a subset. Shown here, instead of asking every single member of the population, I would select members of the population at random and ask them the question. And that is what comprises my sample. Now be careful. If you strictly look at the definition, you would say that the subcollection might be all the females in the class or all the males in the class. In the truest form of the definition, that could be correct. But we want to make sure that our sample is representative of our population. So I wouldn't go and ask all the females or just ask all the males if I wanted to know what the entire class thought about the sports team. So the population, we would then come back and say 75% said the twins. I would say the majority of the students in my class like the twins. Okay? I've made a conclusion about the population based on the sample. And that goes to tell you that our data on our population is only as good as our sample. Okay? If we don't have a sample that represents our population, then our data can be biased in one way or the other. Now, I'm going to ask you to look for a survey or some data and try to figure out what the population in the sample is. And so along those lines, I have some examples picked out. These are called snapshots. You can find them in USA Today, and they just simply sample people and ask them a question. Which person do you most trust to prepare your food is what they ask this group of people. We have to make an inference about the population, but the sample they've told us exactly. They surveyed 1,572 adults. So this would be my sample. Who does this data apply to? That would be my entire population. Well, in general, it would be the entire group of adults that eat, right? Which person do you most trust to prepare your food? So everyone that's eating is having their food prepared, and therefore that would be my population, all adults that eat. And my sample would be the 1,572 adults they ask this question to. I have another example. All right, maybe you can look at it for just a second and see if you can pick out the sample. That's the easiest thing to do in these. If you said it's 2,495 adults, you are correct. Okay, so they asked 2,495 adults what makes us recycle. And now we are not given what the population is, but we have to infer it. Because they say Americans say, all right, we're going to say that the population is the group of Americans that recycle, the entire group of Americans that recycle. Again, it's not given to us, but we have to make an inference about it. But the sample is given to us. If we look at a scientific paper, and I found this one online, and you look through the tables, a lot of times the sample is given to you explicitly when they say n equals. In this case, they have an n equal 100. That was the total number of people that they sampled. What is their population? Well, you'd have to make an inference based on what the paper is trying to distinguish. They sampled 100 people and they're making a conclusion about drug abuse situations among ethnic minorities in Hong Kong. Okay, so the population would be ethnic minorities in Hong Kong, and the sample would be the 100 people that they actually posed the question to, shown here in the table as n equal 100. If you look at weekly polls like presidential approval ratings, and I have one here from Fox News poll, when we look at the sample, a lot of times it steers us to what the population would be. So in this particular poll, they explicitly say it was a random national sample of 1,014 registered voters. So I know that my sample is 1,014 registered voters. That's who actually responded to this questionnaire. And what would be my population? Well, if my sample's registered voters, my population would be the all registered voters. Okay, not just the ones they ask, but all registered voters. In other words, if I come down here and say, let's find us something they ask about. Let's see. All right, here's a question. During the next year, do you think the economy will get better, get worse, or stay about the same? If they report that 32% of registered voters feel that the economy will get better, all right, then we're making that conclusion about the population. The sample showed that 32% of that 1,000 said that the economy would get better. Okay, sample versus population. Now I'm going to show you an example where it's not always easy to pick out the population and sample. Okay, this was something I found online where the government says that 1.77 million students were homeschooled in 2012, and that's an 18% increase. Great data, great statistics, but where did the data come from? So there's no information here to tell me what the sample was. A lot of times it's hidden in the back. If I click on this, all right, it says that the data came from the National Household Educational Surveys. And now I've clicked around on this for a while now, and I cannot find anything that tells me what the sample is. We know that the population would be all households in the U.S. with students or interested in education, but I cannot find the exact number of people that they ask. All right, why is that important? Well, if they only ask 2 people and they're basing their data on 2 people, that's not going to be very good information, okay? But if they've asked 200,000 people, then I'm going to believe this data a lot more. So again, you might pick out a survey with good data, but you might not always be able to find the sample. And in this case, we can glean what the population is, but we can't find the sample. Another common mistake that new statistical students make is they find a census or something very close to a census instead of a sample. Okay, a census is when you ask absolutely everybody or you collect all data available. And one example of that would be looking at something like traffic fatalities. This is more like a census. A lot of students will come in here and say the sample is 348 traffic deaths. That's not exactly true. They are not doing a sample in this case. What they're doing in this case is calculating all traffic deaths. Okay, so this becomes a census. When we have a census, it means that we've asked everybody in the population and there is no sample. Most of the time that's infeasible. We can't do it. However, if we do due diligence and get as close as we can, then we call that a census. So when you're looking at things like fatalities, we do monitor every death. That's why you get a Death certificate, we monitor every birth. That's why we get a birth certificate. We typically monitor crime rates, murder rates, things like that. You're typically looking at a census, which means that they have collected all the data available, and there will not be a sample. There will only be a population. So who's our population in this case? All Minnesota traffic drivers, in other words. What's our sample? Well, there isn't one because this is very close to a census. So I hope this helps clarify population versus sample. And as you do more and more examples of these, it will become more and more clear on how to distinguish a population from a sample.